Hello everyone. I am Aditi Bachcha from AISS College of Engineering, Pune. I am here to explain about capacitive potential divider with my group members Ruturaj Machale, Suyash Srivastav, Vineet Kadve. It is under the guidance of our professor Mangal Dhin. So in this video we are going to talk about what is capacitive potential divider, its advantages, limitations. But before that, we must know what is potential divider, its types and principles. So let us talk about potential divider. It is a simple circuit that is used to measure the high voltages and currents. There are two types of potential dividers: capacitive potential divider and capacitive voltage transformer. So under the introduction, high test voltages generated in laboratories require special techniques for the measurement. Each type of high voltage, namely AC, DC and impulse, can be suitably measured with more than one different techniques. The choice of method of measurement in a laboratory is a matter of convenience, cost and the accuracy required for the measurement besides the safety. So in this chart, according to the types of voltages, there are methods of measurements. Under DC voltages, the methods are series resistance microammeter, resistance potential divider, generating voltmeters, spear and other spark gaps. And under AC voltages, methods are potential dividers, series impedance ammeters, potential transformers, electrostatic voltmeters and spear gaps. Over to you, Ruturaj.
Thank you, Aditi. Now we will see the principle of potential divider. So for the measurement of high voltages of any type, the best technique which can be used is by dividing the high voltage into a low level voltage, which is suitable for the instrument or the measuring circuit which we are going to use to measure the high voltage directly. The arms of the HV potential dividers can be purely resistive, purely capacitive, or they can also be a combination of these two. Means nothing but the mixed potential dividers, where capacitors as well as resistors are used in the circuit to measure the high voltages. The essential requirement to measure high voltage is that the wave shape that is to be measured is correctly reproduced on the oscillograph with a known voltage reduction ratio. So as you can see, this is the principal circuit for voltage dividers. Here Z1 is the arm having high voltage and Z2 is the arm having low voltage. It is shown that how the high voltage can be measured using potential dividers, which are consisting of capacitors, resistors and etc. Now U1 by U2 is nothing but the voltage reduction ratio, and it is given by Z1 by Z2. In this expression, values of Z1 and Z2 are so chosen such that the potential across Z2 arm is around 100 volt. The voltage division ratio is given as Z1 by Z2 is very greater than 1, and where Z2 equal to 1 by Z2 dash plus 1 by Z2 double dash raised to minus 1, where Z double dash 2 is nothing but the terminal impedance of oscilloscope, where we will get the correctly produced wave of voltage which is to be measured. Potential dividers are very accurate in practical to measure the high voltage, and it also provides a continuous measurement of all types of high voltages which are applied, that is DC, AC or impulse. Now let us see about the capacitive potential divider. Basically, as the name indicates, these type of dividers are consisting of various types of capacitors like compressed gas or vacuum type capacitors, which are generally in picofarad range. They are also comprised of number of nanofarad range HV capacitors made of polypropylene material or paper filled with oil, which are built in stack, and they also connected in series. These type of voltage dividers are suitable for the measurement of high power frequency and impulse, that is nothing but the sudden voltages. And the main point for using these type of potential dividers is that the errors produced due to the harmonic voltages can be eliminated by the use of capacitive voltage dividers. With the use of electrostatic voltmeters or a high impedance meters, means meters with high input impedance which draws almost no current through the meter while testing a circuit, such as VTVM, that is nothing but the vacuum tube voltmeter. Now my friend Vineet will explain you about the diagram and operation of capacitive voltage divider. Over to you, Vineet.
Thank you, Ruturaj. Now let's see the circuit diagram and its operation. Circuit diagram consists of two capacitors. Capacitor C1 is standard high voltage compressed gas condenser. It is a 3-terminal capacitor. Third terminal is used for shielding of this capacitor with respect to any stray capacitances present nearby. Capacitor C2 is a standard low voltage condenser having mic or paper dielectric material. This capacitor is also enclosed inside a box, which is a shielding box used for preventing stray capacitances from interfering with the measurements. The next important element of the circuit is high impedance voltmeter or electrostatic voltmeter. It is required to provide proper isolation between the high voltage terminal and the ground. For protecting the electrostatic voltmeter, there is a protective device connected across it in the form of spark gap with suitable voltage adjustment. In case if there is any flashover across any one of the capacitors, then this protective device will be able to prevent damage to the electrostatic voltmeter. The next element that is involved is connecting cable. It is used for connecting this measurement assembly to the capacitance potential divider circuit. Again, this cable is shielded to prevent any stray capacitances from affecting the measurements. Here we observe that most of the circuit is having a complete shielding with respect to its surrounding and hence thereby increasing the accuracy of the circuit. This method, since it uses electrostatic voltmeter and since it has potential divider arrangement, its elements can be tuned in order to minimize the effect of harmonic voltages, thereby minimizing the error. Now let's see the circuit operation. We have already seen first 3 points. Now let's jump to the fourth point. So the unknown voltage that we want to measure, that is V1, is given by V2 multiplied by the ratio C1 plus C2 plus Cm in the numerator and divided by C1 in the denominator, where C1 and C2 are the capacitances that are already present in the circuit. Cm represents the capacitance of meter, lead and connecting cable, and V2 is voltmeter reading. These are the capacitors which can be used in the capacitive potential divider method while practically implementing it as discussed earlier. Now my friend Suyash will explain the advantages and limitations of this method. Over to you, Suyash.
Thank you, Vineet. Now let's see the advantages of capacitive potential divider. Loading on source is negligible. Meter will not consume any power from source. Capacitive ratio is independent of frequency, so the frequency effect will be negligible. Moreover, results are very accurate. The effect of stray capacitance may be made constant in a capacitive divider by shielding the potential divider and hence make an allowance for it. Errors due to harmonic voltages are eliminated. Now let's see the limitations of capacitive potential divider. The disadvantage of capacitance potential divider is that proper termination cannot be done. Selection of high voltage capacitor is very difficult. Circuit needs calibration taking into account the cable and lead capacitor. Need of high impedance voltmeter for measurement like vacuum tube voltmeter. S- So thank you for watching and hope you like the video. If you have any questions regarding this topic, do ask in comment section below and do like and share the video.